Ari and I are on the same team here. The bumper sticker that we have in mind is the phrase that atoms are the new bits. The point is simply that physical stuff is really cool again. And I know that everybody here has an interesting story to tell, and a lot of people have things to show, and I want to leave time for that, and I also want to be respectful of your evenings and all this kind of stuff. So this is, by the way, a preview of my next book, so for those of you who are waiting for the as Ari says, the intellectual property that will hurt your foot if you drop it. I drop it on it. This is a preview of the thesis. Basically, this is the only slide with words, and the point is simply this: that the past decade has been about finding new social and innovation models on the web. We love it, fantastic. The next decade is going to be applying those models to the real world. Web is great, we love it, despite being dead and all that. We live in the physical world, and applying those innovation models that work so well in software to hardware is the exciting new opportunity. Industrial revolutions are, it's big work. It's kind of a world-changing sort of thing. When you look at the first industrial revolution, we took steam power and water power and used it to amplify human power to replace muscles with machines and elevate human potential to more cerebral intellectual pursuits, but it had the consequence of centralizing society around the machines. We had to move to the factories. We left the farms. It's created the modern city, but also sort of concentrated human endeavor around factories. A very sort of institutional perspective on innovation. The second industrial revolution was largely the information revolution, but not the invention of the computer or the mainframe, but more the democratization of that, which is to say, democratization of the tools of prototyping, in this case the first laser printer, the iPad in 1985, and then the tools of distribution, which was the web and the blogs and all this kind of stuff. So you need to do that. You need to be able to make one and make many, to print locally and print globally. And that's how you get a revolution that really deserves the name. The analogy that we're talking about right now is this one. Rather than the laser printer, we have the 3D printer. This is a MakerBot. I think many of you probably already have one. 3D printers and CNC machines and laser cutters and all these digitally driven prototyping tools are now within the reach of everybody. This costs $700. A CNC machine costs $500. A laser cutter can be had for just over $1,000. So that's the make one. That's the print local. The print global is the ability to upload your digital designs to any number of services. I'll talk more about later with the Shapeways, Pinocos, etc., or send them straight to China to be manufactured in proper factories. And the amazing thing about sites like Alibaba and others is that, basically you don't have to be a company. You don't have to be an official, buyer. You can just go onto the site, say, I want a motor made. Who makes motors? They have this IM client that will translate in real time between English and Chinese, and they take credit cards, and they take PayPal, and you upload your design, and 10 days later, the prototypes show up on your door. And if they're good, you order as many as you want, 10, 100, 10,000, million, whatever. It's kind of amazing. You can get, the global supply chain to work for you, just point and click. My own reason for getting in this is that this is my grandfather, Fred Hauser. He was an inventor. He was a Swiss immigrant, came to San Francisco, Los Angeles in the 1920s. And by day, he worked in Hollywood, and Hollywood was a very mechanical business with tape drives and film loops and that kind of stuff. But by night, he invented stuff. He was essentially, as with the cliche of Swiss engineers, he was essentially a watchmaker, and his stuff all involved timing and gears and such. So this is what he had this little sort of drawing board. And this is what he invented. He invented the automatic sprinkler system. If you think about it, an automatic sprinkler system is exactly what a Swiss engineer in Los Angeles would make, which is to say, it's a sprinkler with a watch on it, a timer. It was sold as the Moody Rainmaster, and liberating people to go to the beach and let their lawns be watered automatically. And in those days, if you were an inventor, the only way to get to market was to patent and license. You couldn't be an entrepreneur. You could be an inventor, but you could not be an entrepreneur, because you couldn't make stuff. You could make one, but you couldn't make many. You could print local, but you couldn't print global. So what you had to do was license, was patented, as he did, and license to some company who would then take it and do with it what they wanted. You lost control. You lost the revenues. Basically, you got screwed. Most inventors got screwed. You were disintermediated from the market, and that was the way it was. As a child, this is me at 4. I grew up, I spent my summers with my, I took a small screen, but I spent my summers with my grandfather. He taught me how to do mechanical drawing. And then as I got older, this is me at 12, I was, he taught me how to use a metal lathe. And, every summer he'd say, we're going to build something awesome this summer. I'm like, cool, Grandpa, what are we going to make? This summer we're going to make an engine, an internal combustion engine. And so I was like, okay, cool, I get it, kids. So I said, I looked at the box. And the box came, and I was like, awesome, okay, it's going to be like a plastic model, right? There's going to be a bunch of pieces, and you put them together, instructions. And inside the box were these 4 blocks of metal and a blueprint. And I was like, where's the engine? He says, the engine's in there. We have to get it out. And we spent the whole summer machining the engine out of these blocks of metal according to the blueprints. And this is a totally transformative thing when you're kids. The curlicues of metal build up around your feet. You realize that, like a sculptor looks at a block of marble and just cuts away the parts that aren't the human figure. A great engineer looks at the block of metal and cuts away the bits that aren't the object he wants to create. But I didn't follow his path. I didn't become an inventor because I couldn't see how to get to market. I wanted to be an entrepreneur, and he was an inventor. And there was no way to go from the first to the second. And there's a movie with somebody who may have seen called Flash of Genius about the invention of the intermittent windshield wiper, which has, again, a sort of delay circuit. It pauses if the rain's not coming down very high. This is the kind of the dramatized version of exactly the same deal, right? The inventor, the 12-year-old boy, the making of one. But then he made a mistake, which my grandfather didn't make, which is that he decided not only to patent, but also to manufacture. He wanted to be an entrepreneur, not just an inventor. So he mortgaged his house to build a factory. And, it's hard to build a factory. Years go by, 61, 62, 63, he's still building his factory. 1964, it's a rainy day, he's in Detroit, the factory's still not done. Comes out of the factory, turns the corner, the new 1965 Mustangs are being rolled out to be unveiled, and the windshield wipers go, pause, pause. He realizes that his idea has been stolen, he's ruined. 20th century model is, you want to be an inventor? Good luck. You want to make stuff? You can't. You got to be a company. You got to have lots of money. You got to build a factory. The 21st century model is go for it. Just as the web liberated all of you to become entrepreneurs, not just inventors, to just do it. The mechanisms are now in place that we can just do it. But that's the point. We now have the ability. We are liberated to make stuff ourselves. And because we have the web, and we have distributed manufacturing, and we can sort of upload our designs to any site to have them made, we don't need to own a factory anymore. We can use the factories that are already in existence because they're impedance matched to the individual. This is what we do. We do UAVs. I'll tell you more about it in a minute. But basically, we're an Arduino-based company. We use the Arduino open source hardware platform that I think most of you know. And we just make robot airplanes and robot quadcopters. And if I have a few more beers, I may actually probably shouldn't drink beers and fly quadcopters at the same time. But we basically, our job is to open. So I think many of us here are in open source hardware. What open source hardware does is it disrupts from below. We don't charge for intellectual property, and we don't charge for intellectual property, suddenly costs fall dramatically. So what we do is we basically take military-grade autopilots and we sell them we recreate them, we create things with the same features that are open source, built on Arduino, and we sell them for hundreds of dollars, not hundreds of millions of dollars, or millions of dollars, and we innovate faster, better, cheaper, and we're basically going to try to sort of pick off bits and bits of the aerospace industry, avionics first, and disrupt using exactly the way that you would expect startups and entrepreneurs to do, which is to say, we're not taking manned aircraft grade stuff and making it better. We're starting with toys and making them smarter. And that approach of bottoms up, we're not kind of coming at it from the existing path, but finding a new path based on the fact that your phone can fly an Airbus, right? I mean, those of you who are carrying an Airbus or an iPhone or a new Android, you've got gyros, you've got accelerometers, you've got GPS, you've got magnetometer, you've got wireless, you've got cameras, you've got processing, you've got memory. You can fly an Airbus. All it takes is a dongle. Ari knows something about this, about the dongles. All it takes is a dongle to interface with the hardware of the aircraft. You can fly a plane with an iPhone, right? They just now qualified the iPad for the cockpit of passenger planes. The question now is, what belongs on the cockpit, what belongs on the plane, and what belongs on the iPad? Which one of those dials would be better off as an app than a $10,000 bit of equipment? That's the kind of disruption that can happen once you sort of liberate the market from the existing parties. We use Ketzoff's Eagle PCB design software. This is the schematics. These are the board files. It's free. Anybody can use it. I'm not an electrical engineer, and these are the boards, and I'm designing autopilots. In the end, we do this. We make pretty sophisticated electronics. We have pick and place machines and reflow ovens and all this kind of stuff. And it costs like $200, and next year it'll cost $100. And we make it super, super cheap and available to everybody. Not because we expect the military to use this. We don't want military to use it, but because we want to get everyone else to use this. My children are flying drones. There are engineers everywhere in school who are learning aerial robotics this way. It's the future of aerospace, and it shouldn't cost $100,000. It should cost less than $1,000, which is our approach. Unfortunately, my screen resolution screwed up a bit, but basically we sell it as a kit in the United States, and we sell it as an assembled product in Mexico. As a kit, it's not export controlled because it's not an autopilot. It's just a bundle of parts. Once you put it together and add the code, the code can move around because it's public domain. The kit itself is simply a bundle of parts. It's not an autopilot. Once you put it together and add the code, now it's an autopilot that's export controlled. So we simply just put, we do regulatory arbitrage. We do the work, we're a global company, global development, and we just put the work where the regulations allow it. And we're like water, we just flow to where regulations are lowest. And because we're a global community, we're completely agnostic. We have factories in Bangkok and Tijuana and San Diego. And we simply go where the environment is most friendly. So everything's better when it's open source. Not because the product itself is going to be better at the core functions, but because it enables new functions. It puts in the hands of people who can think of applications that you never would have thought of yourself. And once you open up, and by the way, the ones I just listed are the first ones that came to my mind. I'm sure better, with hydroponic pot being a great example, but different applications will come up once it's in the hands of regular folks. The point is simply this, that making is manufacturing. For the first time in history, you can go from one to many without having to build a factory. You can use Shapeways and do your 3D printing, just upload your files. You can use Pinocchio and upload your files for laser cutting and 3D printing. And, it's easy. There's absolutely nothing, and many of you are probably already doing it. What we're creating is an opportunity to kind of rewind the clock. When I showed you that first slide of the Industrial Revolution, I said people left the farms and went to the factory, but that was a lie. There was a step in between. And the step in between was the cottage industry. They actually, it was the kind of human-powered looms that were the intermediate step. And what the looms did is they largely empowered women to leave the farm and to go and to become entrepreneurs, build small businesses at home using the small looms that empowered them and amplified their potential. Later, it went to water and steam power and scaled up to industrial scale. But the first step was distributed manufacturing at a cottage level, largely driven by people who had no experience in manufacturing, but became entrepreneurs. And the question is, are we going to go the other direction now? Is this now a chance to go back to the cottage industry form of manufacturing with whatever the loom equivalent is today, and see the economic engine of America is traditionally small business and entrepreneurship, but not in manufacturing because the barriers to entry are too high. Do these tools and this access to manufacturing, this ability to kind of trade digital files and use web innovation models allow us to invent a new manufacturing industry that's built around Silicon Valley lines of small, nimble startups rather than massive manufacturing giants with multi-billion-dollar facilities. So there's our slogan, add such new bits, and that's my story. Thank you.